Okay, this is video number 2. So, kinetic energy. Simply, it's the energy due to motion. It depends on mass and speed squared. The formula for it, EK equals half mv squared. So an example would be a car is driving along at 25 meters per second. What is the kinetic energy of the car if it has a mass of 1000 kg? So just putting into the formula, EK equals half mv squared, so it's going to be half times 1000 times 25 squared. So that equals 313,000 joules, or 313 kilojoules. So gravitational potential energy, this depends on the mass at a certain height, h, okay? It's given by this formula, EP equals mgh. We could define it as energy, energy a mass has depending on its position in a gravitational field. So an example of this, let's say we drove that car from before, 1000 kg car, to the top of a hill. Okay, and the hill was 100 meters high. So what type of energy does it possess? Let's have a look. EP equals mgh. So its mass, which is 1000, times gravity, which is 10, times the height, which is 100. So you've got 1, 2, 3, 4, 5, 6 zeros there, so we've got 1,000,000 joules of energy. Now if he actually drove off the end and came down just before it hit the ground, what would its kinetic energy be? Well, the kinetic energy would be equal to 1,000,000 joules. Okay? And you could actually solve that by saying that 1,000,000 is equal to half times 1000 as mass times speed squared. Okay? You could try it yourself and you should get a speed of 44.7 meters per second. Okay, this one you're going to do yourself. Okay, you can find out where to do this in the good resources will be your textbook or any Google of IGCSE or GCSE. And one of the last things we're looking at is E equals mc squared. This formula essentially says energy equals mass times a constant, in this case speed of light, squared. Okay, where speed of light is 3 times 10 to the 8 squared. Very big number. So what we're saying here is that you can convert energy into mass and mass into energy, or in fact, because it's an equals, they are one and the same. efficiency. Efficiency is really how economical or how good a particular device is. Let's say we had some couple of wires going to a big motor. Okay, so here's our motor, and it's turning some sort of fan like that. Now, as this thing is rotating, there is 100 joules of energy going in, let's say after 1 second. Okay, there's 100 joules of energy going in. The output power of this fan is 35 joules. Okay, so this thing has actually lost 65 joules to heat or sound. So what's the efficiency? Well, we know that we would do 35 divided by 100, so our output divided by the input times 100, and that will give us 35% efficient. So what's the formula going to be? So efficiency equals output, in other words useful energy, divided by input or total times 100. So an example, we just had one before. Let's say using that motor before, or a similar one, we have it sitting on top of a bench top, and we raise a mass up to the top. Okay, it's a 10 kg mass, and we're raising it 10 meters. Okay, and let's say we put in 10,000 joules of energy into this motor to raise this object. So let's work out what energy we actually require to get it up there. Okay, what do we require? So that's potential energy, so it's going to be mgh, so it's going to be 10 for the mass times 10 for gravity times 10 for the height, and so 10 times 10 times 10 gives you 1,000 joules. Now if we put in 10,000 joules, let's look at the efficiency. So it's your output, which is 1,000 divided by 10,000 times 100. Okay. Now you notice that there's a lot of energy in this case gone into wasted energy, so heat and so on. It's about 90%.